Our topic today is Introduction to Integers. The essential questions are: which numbers are integers, what are additive inverses, and what should you know about distance and length? So we'll start off with the definition. Any whole number and its opposite, and 0 is an integer too. So any whole number, its opposite, and 0, they're all considered integers. Okay, so we'll start off with some examples of integers. Think of a whole number, and I'm going to think of 5, and think of its opposite, -5. So 5 and -5, those are examples of integers. We also know 0 is an integer. It's right in the definition right there. You could say 1,000. You could also say -1,000. You could say 40, -40. You could say 6 and 0/10, because that's just 6, which is a whole number. You could say -6 and 0/10. So those are all examples of integers. Here are some non-examples of integers. Let's say 6 and 100th. That's not an integer because it is not a whole number. -6 and 1/100th. 75/100ths is not an integer. 2/3 is not an integer. 1/5, 1/8, 425 thousandths, -1/8, -1/5. Those are just some examples of non-examples of integers. The next vocab word that you need to know, its definition are two numbers whose sum is 0, and the key important thing is they're opposites. They're opposites that add up to 0. That's the definition for additive inverses. Okay. Additive inverses are two numbers whose sum is 0, and make sure that they're opposites that add up to 0. I've also seen them called 0 pairs, so I want us to add that they're also known as 0 pairs. Here are examples of additive inverses which are also integers. So we have -3 and 3, because when you add them together, their sum is 0. Other examples of additive inverses could be 4 and -4, because when you add them together, their sum is 0. Another example of an additive inverses which are also integers would be 1,000 and -1,000. And I'm putting parentheses around those negative values just to show you that that's a -4 and that's a -1,000, in case you're wondering what I'm doing. So 1,000 and -1,000 are also examples of additive inverses which are also integers. See how their sum, when you add them together, is 0. Okay, additive inverses can also be numbers that are not integers. So here are some additive inverses which are not integers. -1/2 and 1/2. Those are additive inverses, but they're not integers. They are additive inverses though, because you'll see that they have a sum of 0. 2/8 and -2/8. Those are also additive inverses because their sum is 0, but they're not integers because they're not whole numbers, or they're opposites. Okay, and let's throw in a decimal, -75/100ths and +75/100ths. Those two are examples of additive inverses simply because when you add them together, their sum is 0. So for the summary section, I want you to go ahead and answer these questions, and please answer them or you will not receive points for your notes. Okay, so the next problems have to do with with solving equations and displaying them on a number line using vectors to kind of model what exactly is going on when you're adding or subtracting these integers. Okay, right here is a vector. This is an example of a vector. You'll be dealing with those in 8th grade, but I'm going to introduce them to you now in 7th grade. So it's really just like a ray, but it's got the little dot at the end to show that it stops. So it's got a starting point and a stopping point. So it goes all there and it stops right there. Okay? The positive and negative, or the plus and the minus, basically tell you direction. So right here we have 5 minus 11. And when you're modeling this on a number line, you want to start at 0, okay? And you're going to draw your vector to this positive 5. So that's where you're starting at. It's positive 5 because there's no negative in front of it. So you're going to go to the right all the way until you get to 5. And then your vector stops right there. Okay? And then it says minus 11. The minus indicates you're going to go to the left, 11 units. So from that 5, you're going to start that vector, and you're going to count over 11 units. So there was 5 units right there. 6, 7, 8, 9, 10, 11, right there. Okay? And to double check, you can always count it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 units. So your answer to 5 minus 11 is going to be negative 6. Number 2, it's got a different starting, or it's got, you're going to start at 0, but it says negative 3 plus 10. So when you're drawing your vector, you're going to start at 0. You're going to go to the left 3, because that shows your direction. And you're ending your vector right there. And then it says plus 10. You're going to go to the right 10 units. But you're going to start your vector right there at the negative 3. And you're going to go to the right 10 units. And there's 3, 4, 5, 6, 7, 8, 9, 10 units right there. Okay? And you can always double check by counting them in case it's challenging to draw that line right there for the vector. And our answer to negative 3 plus 10 is 7. So that's what you're right up there to that equation. Negative 6 minus 3. So start off with that first number that you see right there. It says negative 6. So you're going to draw your vector from 0 to negative 6. And then it's saying minus 3. So your direction that you need to go is to the left 3 units from that negative 6. Okay? So negative 6 minus 3 is negative 9. And that's your solution to that equation. Okay, I threw this one in there just to kind of give you some practice with the direction and using vectors to model it on a number line. So we're starting out with 5. So you're going to start at 0. And since it's a positive 5, you're going to need to go to the right 5. Okay, so we got that. If it helps, you can cross them off as you go. And now I see that it says minus 7. Oops, sorry, my vector is a little off. It says minus 7, so that means from that 5, I'm going to go to the left 7 units. Okay, so we got those. So 5 minus 7 is negative 2, so that's where we're at. And then it says minus 3, so again, since it's minus, you're going to go to the left 3 more units, which brings you to negative 5. Okay, now it says plus 6, so now you're going to go to the right 6 units from that negative 5. Oops, sorry. Okay, which brings you to 1. Okay, now from there, from that 1, you're going to go to the right 3 more units because it says plus 3, which is going to bring you to 4. Okay, and it says minus 5, so from there you're going to go left 5 units. Should bring you to negative 1. And now you're going to go to the right 2 units. Okay. So it might be a little bit hard to see, but you'll see when you line it up, our answer is positive 1. And your summary is to draw a vector right in this little space right here. I also want you to know that you shouldn't be afraid to rewrite a problem's order. You'll still get the same answer thanks to the commutative property. But just know that if you simplify the expression first before starting to move the numbers around, it might be a lot easier for you, okay? So right here we're going to be practicing solving these problems, and then we'll practice rewriting them and then solving them again. You'll see that you'll get the exact same answer, okay? So we have 5 minus 11. And we'll use our number line to help us solve this. 5 minus 11. So it's a positive 5. So we'll be right here. And since we're subtracting 11, we're going to go to the left 11 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. And our answer will be negative 6. I didn't use vectors to model this just because I'm trying to go kind of fast for this. So our solution right here is negative 6. Now we're going to rewrite it and solve it again. So right here we see a minus right in front of that 11, so we're going to keep it like that. And then this is a positive 5 right there. And let's go ahead and solve this. It's negative 11 plus 5 this time. So we're going to start at negative 11, and we got to go to the right 5. So 1, 2, 3, 4, 5, and you'll see we will still get negative 6 as our solution. Okay, the next problem says negative 4 minus 6. Using our number line for negative 4 minus 6, we're starting at negative 4 right here, and we're going to go to the left 6 units. So 1, 2, 3, 4, 5, 6 puts us at negative 10. Sorry, that's a subtract. So put negative 10 right here, and we're going to rewrite it and solve it again. So you see there's a minus in front of that 6, so make it negative 6. And then a minus, or a negative, same thing, in front of that 4. And we should still get the same solution. So negative 6 minus 4, there's negative 6. And we have to go to the left 4 units. So 1, 2, 3, 4 puts us at negative 10. Okay, the next problem says negative 3 plus 5. So using our number line, we're going to start at, negative 3, and then we're going to go to the right 5 units. 1, 2, 3, 4, 5. That puts us at positive 2. You can just write 2, okay? Same thing. And we're going to go ahead and rewrite it. Keep the symbol directly in front of it. So that's a positive 5 and a minus 3. So it's really 5 minus 3, and I think you know that is 2. Okay, the next problem is 10 minus 12. So 10 is over here, and then it says minus 12, so we're going to go to the left 12 units. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our answer is negative 2. And let's go ahead and reverse the order. Negative 12 plus 10. And let's see right here, negative 12 plus 10. So we're going to start at that negative 12. We're going to go to the right 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Puts us at negative 2. Okay, right here, I got negative 3 plus 2 plus 3. So let's go ahead and start at that negative 3. Well, let me write it for you. Negative 3 plus 2 plus 3. So we're at negative 3. Because it's negative 3, and then we got to go to the right 2 units. 1, 2 puts us right there, and then we got to go to the right 3 more units. 1, 2, 3 puts us at 2. Something I want you to notice right here, you'll see that we have a negative 3 and a positive 3. Remember, those are additive inverses. They're going to equal 0. So when I go to rewrite this, I think it'd be nice to put them right next to each other, because then I can identify right away that they're 0 pairs and they'll equal 0. So I'm going to write that positive 3 first, then that minus 3, then I could put that plus 2. So now when you look at it, you're like 3 minus 3, well that's 0, plus 2, that's 2. Okay, your next problem. Oh, look. Remember how I told you up here, simplifying expressions first before changing any order will help make it easier? So you've learned that when you see parentheses, I also want you to look directly in front of it. If there's a number or symbol directly in front of it, you need to use that distributive property. You need to multiply it through. So right here, you see that there's a negative right next to those parentheses, so we're going to multiply that. Negative times a negative 6. Negative times a negative 6 is a positive 6, okay? Then bring down your negative 3. So now we're going to look at this, negative 3 plus 6. That's the one that I'm going to be looking at right here. Negative 3 plus 6. So that's a negative 3. We start right there. Got to go to the right 6 because it's a plus. 1, 2, 3, 4, 5, 6 gives us positive 3. Okay, and when I rewrite the order, I see it's a positive 6. and a minus 3. 6 minus 3, I think you know, is 3. Okay. All right here. Oh, parentheses again, and I see directly in front of them, I see a symbol. So a positive times a negative 3 gives me a negative 3. Bring down that negative 6. So now my problem is negative 6 minus 3. Okay, and we're going to start over here at the negative 6. It's a minus 3, so we're going to go to the left 3 units. 1, 2, 3. So that puts us at negative 9. Okay, and when you go and you rewrite the problem, you're going to put this first, that negative 3 or that minus 3, and that minus 6. Negative 3 minus 6. So we're going to start in negative 3. We're going to go to the left 6 units. 1, 2, 3, 4, 5, 6. And that puts us at negative 9, which is the same answer. Okay, so it's okay to switch the order of the numbers as long as you keep the sign in front of it. But remember, if you see anything where you can simplify it more, like right here where we're subtracting a negative, where you know that means multiply, go ahead and rewrite it so it's so much easier when you switch them, so it's not all crazy. Okay, right here, the last one I'll help you with. Positive times a negative gives me a negative, so this is negative 7 or a minus 7. Bring down your 5, so it's 5 minus 7. Okay, so we're at, where's 5? Oh, there's 5 right there. We have to go to the left because it's a minus 7. Left 7 units. 1, 2, 3, 4, 5. 6, 7, so negative 2. Okay, reverse the order. That's a minus 7 or a negative 7. That's a positive 5. Negative 7 plus 5. Let's go ahead and look it over here. Negative 7 plus 5. That's a 5. So we're at negative 7. We're going to go to the right 5. 1, 2, 3, 4, 5. That's negative 2. Okay? Okay, for your summary, I want you to answer these. Okay, 9, 10, 11. Right here, please remember what this turns into, a positive times a negative, okay? If you need it, this can help you. Remember, this only works for multiplication and division. And this right here, it's multiplying, so a positive times a negative gives me a negative, so this really turns into a minus 2. So it's really 3 minus 2. So you're going to write your answer here and also rewrite it and show me the answer again, okay? All right, bye.